All right, this is our last percent use for our lessons. So we're going to be done with percents after this, more or less. We're going to look at compound interest and continuous interest. These two formulas are a little bit more difficult, so notice I'm not talking about simple interest. The calculations are not really that much different. Notice that it's a 1 plus a number, so this means it's always increasing. That's why we've been doing those percent increase problems. A is the amount at the end. So in this case, we're always going to find that final amount, not the interest amount. So the amount at the end equals the principal or the beginning amount times 1 meaning 100%. If I'm going to earn interest on something or have to pay interest, I'm going to be charged on the entire amount that I borrowed or invested first. And then I'm going to add on the little bit that's going to be charged with the interest. So R is our interest rate, again as a decimal, divided by N. N is the number of times interest is compounded. And what that means is you get interest earned more frequently than you would simple interest. So it could be yearly, it could be monthly, it could be quarterly. There's all kinds of numbers that go along with that. Raised to the N, so that same compounded number, times T, which is years. So if you're going to evaluate this, remember you're following order of operations. I'm going to do the parentheses part. I'm going to divide. I'm going to add it to the 1. I'm going to raise it to that exponential power and multiply by the P. Now, when we do this, I'm not going to do this. I'm going to simplify this whole thing as much as I can and then do the multiplication, because our calculator, most of us have, has the ability to raise it to that power. If you had to do this step by step, then you would have to show this little difference here. So the first example says, how much money is in an account after 10 years if $600 is invested at 4% interest compounded yearly? So let's look at the numbers they give us. 10 years, that's time. $600, that's P. Invested at 4% interest, so there's our R. That again, we're going to make into a decimal. And compounded yearly, so that's our N. Now this is a silly question because they're telling you it's going to compound yearly. So when we do this, N is going to be 1. So you can see I'm going to divide by 1 and raise something to the 1 times a number. Okay, that's just silly, but we'll go for it. So if I'm going to solve this, setting up my equation, I want to know the final amount if I invest $600 at 4% compounded yearly, raised to the 1 times 10 years. Okay, I'm going to simplify this as much as I can before I try and put this in my calculator. If I don't, the calculator might not understand, and then it's going to give us ridiculous answers. So I want to encourage you to always simplify. Okay, 1 plus 0.04. 0.04 divided by 1. I'm going to leave it this way because normally I would not go ahead and add this, but you can. All you guys know what that's going to be. Raised to the 1 times 10. So I've got $600 times 1.04 raised to the 10th power. Now again, if you don't have a calculator that can do the exponent, well, everybody has a calculator that can do an exponent. If you were supposed to show all your work, I would do this part, but we're not going to do that. So it says in my calculator, I can type in 600 times, if you have a really good calculator, you just put the parenthesis in there, 1.04, close it, raised to, that's my little caret key, the 10th power. And when I do that, I get $888 and 0.146. Remember that this is money, so I'm always going to make sure I round it properly. 15 cents. This is money I have invested. I don't want them to cheat me out of that partial penny. We talked about that with markups and discounts and taxes. You're not going to want to get cheated out of what is owed to you. So make sure you round that ending part. Always, always, always. Now the next part, question, has a little bit better decimal to use in this. And so we're going to look at one that has a little bit different numbers going on there. The next one says, how much money is owed on a 20-year loan compounded quarterly if the initial loan was for $150 at 3.5% interest. Okay, I don't know. This is like one of those rent-a-centers. You're buying a $150 little computer or something, and you don't have any money to do it, so they're going to charge you interest for 20 years. Okay, this is ridiculous, but whatever. A 20-year loan is my T, compounded quarterly. That's my N, and quarterly means 4, like 4 quarters. And then 3.5% interest is my R, and my principal is P, $150. All right, so if you're some kind of poor person, idiot person, taking out a 20-year loan on a computer that costs $150 or whatever this is what you're going to owe at the end. So $150 times 1 plus interest rate 3.5%, 0.035, divided by the number of times it's compounded, 4, raised to the 4, number of times it's compounded, times 20 years. Okay, again, simplify as much as you can. 1 plus, okay, 0.035 divided by 4 is 0.00875 exactly, raised to the 4 times 20, or 80. In my parentheses, I have 1.00875. I never want to round this if it gives me something exact like this. If I do round it, I'm going to take this out to at least 4 decimal places before I do round it, raised to the 80th power. And when I do that, I'm going to multiply 150 times 1.00875 raised to the 80th power in my calculator, and I'm going to get 301.144. So it's $301.14 or 14 cents. So my $150 item just cost me $301.14, or another $151.14, because I borrowed it on a 20-year loan. All right, let's look at what happens if I have the answer, but I don't have the amount that I started with. Now, you might say that that seems silly, and yeah, I would definitely agree, but every once in a while, some people do find some money that was left to them, and they're like, I want to do that all over again. Maybe I should try it. How much money should I put in there? Or maybe you have a goal in mind. Anyway, so Stacy's mom invested money in a savings account, paying 6.8% interest. There's our rate. Compounded monthly. Monthly is our compounded time, and there are 12 months in a year. The account is now worth $1,403.60. Okay, this is now, so that's A. After 5 years, there's my T. How much did Stacy's mom put into the account 5 years ago? So this time I'm looking for P. So I have $1,403.60 now in my account. I don't know what P is. 1 plus my interest rate is 6.8%, 0.068 compounded monthly, so divide by 12. And then I'm going to raise it to the compounded 12 times 5 years. Just like before, we're going to simplify this a little bit. So I'm going to have $1,403.60 equal to P times 1 plus 0.068 divided by 12. Okay, when I do that division, I get a decimal, 0.00566666666. So I'm going to do 6, 7. Again, I'm going to take this out as far as I can to make sure that this is exact. Raise it to 12 times 5, or 60. So in that parentheses, I'm going to go ahead and simplify it, because I have to now follow SADMEP, or the undo order of operations, before I can proceed with this. This is not a root problem, it is an exponent problem first. So in order to simplify this, I have to raise 1.00567 to the 60th power. When I do that, I get a ridiculous decimal that is p times 1.40388. And again, I've rounded this. Now finally, p times this number, so to SADMAP it, I'm going to divide $1,403.60 by 1.40388, and my principal is going to be 999.89. So we're going to assume, even though this is a pretty decent answer, I would almost assume it's $1,000, because had I carried my decimals out further, I probably would have got $1,000. I'm not always going to round these, but usually I do. All right, in the next video, because this one's dragging on, I will show you guys how to calculate continuous interest, which is really pretty easy.